remind you of the steps because we wrote these down to remind us today of how to do this one more time since it's been a minute. Okay, so how to draw a triangle with the compass. Draw the longest side, dot each end, set compass to the next measurement and draw an arc. Then set the compass to the other measurement and draw an arc on the other dot. That's the most important part, the other dot. Where the arcs cross, put a dot. So that's where they cross, put a dot. Connect the dots, create a triangle. These two have to be straight lines connecting the dots. I saw some crazy stuff second and third period on Friday. So, all right, let's move on. So what we're going to do is I'm going to walk you through number 3. The staple might get in the way, so be mindful of the staple. It might get in your way. Construct a triangle with sides measuring exactly 3, 5, and 7. So according to what I just told you, you're going to start with the 7 centimeters. So down low, you're going to start with 7 centimeters. So here I am, 7 centimeters. Seven centimeters there. All right, we're good. Everybody's on task. Everybody's good. Don't fall behind. Remember, the screen nearest you might be easier to see. All right, so I'm done with the 7. Now I have 3 and 5. Oh, I have the dot. Dot and dot. Okay. Choose one, 3 or 5.
3.
Does it matter?
No.
Just as long as you do both. So yeah. 3, 5, doesn't matter. I'm going to use 5 because my compass is already set to 5. You want to do 3, David? Go ahead and do 3. Doesn't matter. Remember the bump that you felt? The bump on the magnifying glass goes here. So the bump on the dot, the bump on the dot. To the best of it, you're going to do an arc. Careful that the staple doesn't get too much in your way. All right, now I got the 5 done. Now I'm going to take and do the 3. So 3. Now use the other bump, other dot. That's the number one thing. You got to use the other dot. What's the one thing kids forget to do is use the other dot. You want to see where they connect. Ooh, mine barely connected. You see they barely connected. If I were to draw this like shorter, I would have to go back and draw the 5 longer. So you want to make sure that they connect. You want to make sure that they connect. So you're drawing the 2 arcs to see where they connect. I barely drew 5 long enough. All right. Now here is where I draw a dot, right? I draw a dot right there. And that's the top of my triangle. That's the top of my triangle. So I'm going to connect bump to dot. Jamie, is that okay? Is it working now? To the right is tight, to the left is loose. Righty tighty, lefty loosey. All right. Now we're going to measure this. Label it 5 centimeters. You're going to thank me later for labeling this. 3 centimeters. You're going to thank me later. So 5 centimeters and 3 centimeters. Good? All right. Can you guys go by yourselves now?
Miss, come on. I've been doing this.
You sure?
David. Is your name? I guess you are, Miss.
So try to do it by yourself. I'm going to do it without talking. If you need help, you can see. You're looking for triangles. Looking for triangles. You're looking to create triangles. You want to give yourself enough room. So you want to draw the line pretty low, so you draw your arcs on top.
Bless you. Oh wait, did we do the other one?
Are you waiting for me?
No, oh no, I just like
You're so kind and polite to wait for me, but give you a head start.
Wow.
What's up?
The other numbers. What did you say?
Oh. All right, and there's two more on page 3. Surprise. It's a surprise. All right, make sure that you have triangles. Make sure that you have triangles. The arcs are just there to help you. They're not considered part of the triangle. All right, did we successfully do these 2 triangles?
No.
Yeah.
Yeah.
Okay.
Didn't he know something? Did he mess up somewhere?
He's just not done.
Perfect triangle.
Thanks. I tried my best. All right. Once you're done that, you can move on to 7 and 8 on the next page. 7 and 8. What do you mean? What are you guys talking about?
7 no connectation.
Can you guys chill? Like, I haven't even done it myself. Oh.
Don't ruin the surprise for SJM.
Cool.
If I print out your results, it won't show the district average. Would you still want your report?
Yes.
Okay.
So my papa.
Your papa. Okay. Did you guys finish 7?
No.
What's wrong with it?
It doesn't connect.
All right.
Just give me time. I'll know what to do, guys.
What's up with number 8?
Not a problem.
It's an isosceles.
Isosceles.
What does that mean?
There's only 2 isosceles.
Number 8, you must use your English skills more than your math skills. There is a number that is missing on number 8. Can you discover what number is missing with by using your English skills, we're going to give everyone 30 seconds to figure it out. But if you figured it out, go ahead and draw it. Prove it to me. What about number 7?
Riley?
Well, we in there, but yet kids in the back are still questioning it, so it's not a we know.
Yeah, Riley. I'm still not even done with number 7.
Knock in, Sam.
Yeah. I'm just being really precise with this little ruler.
What is? Don't answer it. What is a hidden number on number 8? You need your English skills. More than 3. Noah, what is it?
5.
Why?
Because it says sides, so both sides.
Sides. What does S mean in English?
More than one.
More than 1.
So if I say no less, there's no.
No. Depends how you use it.
So yes, Noah saw it. Has S right there. And S in English means more than 1. It also has a base of 3. So I'm going to, fine, I'll do a base of 3. Does it matter? Not really. Then 5 and 5.
You can do any base.
Well, they said base of 3.
Oh.
They said a base of 3.
The others haven't been saying that threw me off, you know what I'm saying?
Yep. That's why you follow Miss O'Malley's steps of do the longest line. The reason we do the longest line is so your arcs aren't ginormous. Imagine having an arc of a 5. Could possibly bring chaos into your life.
So, Miss, what do we do about 7?
It is a triangle that you cannot construct. There are triangles that are impossible. You cannot. You might have had that question on the map test. Are these 3 numbers a possible triangle? And you're like, but I don't have a compass. Well, I didn't even teach it to you back then. It was on your homework last week, but I had you skip it. Some of you try to answer it, which is great. Great to see the effort. In a couple of days this week, I will teach you what makes the 3 numbers a triangle and what makes the 3 numbers impossible to make a triangle. Does anybody know why 2, 4, and 7 do not make a triangle? Why these numbers is no bueno. They don't meet. No bueno. Because what? They're not friends. I get it. So they can't hang out. So they can't meet and make a triangle. You are correct, Evelyn. Make sure you answer that on the S back, okay? Because they're not amigos. Do not force the friendship. You will exceed the math standard. All right. We good? We ready? Yeah? Look at that beautiful isosceles triangle. Look at that non-existent triangle because they're not friends. They're not friends.
Miss, is it because
It's just one thing.
is it half? It's half. You know, because you have to put 7 at the bottom
Very
because it's the
low
longest, and they don't connect because 2 is half 4.
2 is half of 4. Okay, interesting. All right. Okay, I like it. I like your thinking. The reason 7 is at the bottom is 100% because of me. Like, I am making you do the 7 at the bottom. Just because I like the longest line at the bottom. That is a personal teacher's choice. You can make any of these numbers the bottom. You can make any of these numbers the bottom. The reason I have you do it is so your arcs aren't huge. So I'm the one who's making you do that. Because you can make the 3 the base or the 4 the base. But you're onto something. You're not 100% incorrect or 100% correct, but you're onto something. All right, let's move on to page 4 because I got to teach you some stuff today. I got to teach you some new stuff. Actually, maybe you already know this.
Oh, yeah.
When that time comes in a triangle's life and it's born a triangle, it is given a name. It's given a first name and a last name. Like most of you have a first name and a last name. It's a very important moment in a triangle's life. You can name a triangle based on the angles.
Triangle Arteaga.
There you go. Okay. So, number 1, we can call a triangle a right triangle. What makes a triangle a right triangle? And these are not right triangles. So what makes a triangle a right triangle? Yes, Scarlett.
Like triangle. Inside the triangle match up to 90.
All the angles add up to 90? All the angles? Okay. So these are 2 examples of right triangles. And these are 3 examples of non-right triangles. So what makes, Scarlett, maybe elaborate some more or rephrase what you told me. What makes a triangle a right triangle? All right, Emmanuel, try it out.
They have a 90-degree angle.
Yes, they have a 90-degree angle. What does that mean? How many angles are 90 degrees? 2? 3?
1.
How many? 1. So a right triangle has, okay, we should be done with the compass. So the compass should be on your table. Has
Daniel.
one 90-degree angle. Has one 90-degree angle. Not 2. Can't be 2 because then you start doing a quadrilateral. If you have 2, you end up not with a triangle. Impossible. So it has one 90-degree angle. So here's my 90 degrees, and then you know that little square means 90 degrees. So you can call a triangle a right triangle if it has one 90-degree angle. Okay, you can also look at the angles on number 2 and call it an acute triangle. What makes a triangle an acute triangle? So Emmanuel, how can you tell what makes a triangle an acute triangle?
It has one or more acute angles.
One or more. Not quite. Not quite. You have to be more specific. How many angles here are acute? All of them. How many are here? How many does this one have? This one has how many acute angles? 2. This one has how many? 2. But they're not acute. They're not acute. So in order for it to be an acute triangle, it has 3 all acute angles. All of them. All of them. All 3 are acute. Has all. Maybe I should write all right there. Has all 3 acute angles. And just if you don't remember, what is acute?
Smaller than 90 degrees.
Yep. Just if you don't remember, acute means less than 90 degrees. So in an acute triangle, it's so cute, it's so small, because all of your 3 angles are acute. Please. Okay, number 3. Number 3. You can also call a triangle an obtuse triangle. An obtuse triangle. What makes a triangle an obtuse triangle? What?
More than 90. Less than 180.
Velasquez, what is it? Yes. An obtuse angle has one obtuse angle. And just to remind you, what is obtuse, Noah, right here? Measures more than 90 degrees. So an obtuse triangle has one obtuse angle. Obtuse means more than 90. So here's my more than 90. Here's my more than 90. Can I have 2 obtuse angles in a triangle? No, you cannot construct a triangle that has 2 obtuse angles. You end up with a different shape, not even a triangle. We're good? Are we okay? All right. Page 5.
See.
Now, when a triangle is born, it's also given a second name based on its sides. So one is based on the angles, and the other one is based on the sides. So the first possible name is called a scalene. A scalene. What makes a triangle a scalene triangle and not a scalene? What makes a triangle, Kyle, scalene?
Scaling has no equal sides.
Yep. A scalene triangle has no equal sides. But Kyle, you're also right when you slipped in the word angles. Here is a secret. If it has no equal sides, then it also has no equal angles. No equal sides, no equal angles. No equal sides, no equal angles. Same thing. No equal angles means no equal sides. So you can also tell by that. Okay. But scalene is by the sides. No equal sides. See how all the sides are different numbers? Okay. Now, number 5 is a new vocabulary word for some of us. Isosceles. Now there's a mistake. Everybody do this. Everybody circle this triangle right here. This triangle right there. Circle it and draw an arrow to the bottom. It's misplaced. It's not supposed to be there. At the bottom. All right. So everybody circled that one. Okay. Now, isosceles. What is an isosceles triangle?
Same size.
More specific. Okay, Kyle.
Triangle that has two congruent sides.
Two congruent sides. And what does the word mean, congruent? Equals. Yeah, same. Okay. You guys see these little lines? So sometimes they don't write numbers. They do these little tally marks. If they have the same amount of tally marks, that means, Santiago, that they are equal. So you see how this one has 5, and this one has 2, and this one has 2? So that means that they are equal. So instead of putting like the numbers, like the triangle we just drew last, they do these tally marks. So you see how this has 2 tally marks, and this has 2 tally marks? That means that these two sides are equal. They love to do this in high school geometry. Then this has 3, and this has 3, so these two match. Okay? So instead of writing numbers, they do the tallies. All that means is the same. So isosceles has 2 equal sides. So it has 2 equal sides. If it has 2 equal sides, then it has 2 equal angles. But that's a little more advanced. Has 2 equal sides. All right, we're missing one. We're missing a word. What do I call a triangle that has all equal sides?
Equilateral.
Yeah, it's in the name. Emmanuel, was that you? Equilateral triangle. So that's the new vocabulary word for some of us. An equilateral triangle. It's in the word equilateral. Equilateral has 3 equal sides. And if it has 3 equal sides, then I mean it has 3 equal angles. And there's only one measurement for equilateral. Does anybody know what the angles have to measure in an equilateral triangle? It's okay. Huh? Yes. How'd you get that?
Oh, I get it.
Oh, wait. Oh, I get it.
Good job.
180 by 3.
Yes, because what do triangles equal to? 180. And how many angles? 3. Good job, Padilla.
Kid in elementary
You
always
can
says
count
it's
on
the last
you.
clap.
All right. Here we go. Page 6. Página 6. All right. We're moving right along. All right. This is where period 2 and 3 are starting today. Okay. A triangle with sides measuring exactly 2, 4, and 5. So go ahead and do that. 2, 4, and 5. We should be able to do that quickly.
Easy peasy.
Wait, can you stop clapping?
I know that if you're clapping, you're not working because you need 2 hands for this.
Keep going.
This is fun.
Let it live.
Oh, there's something on my leg.
Okay, boys. So is this what Miss Gonzalez was talking about?
Yep.
Yep.
Oh, I get it now.
The the one that cried because we walked in.
Yeah, because y'all are literally so loud. That's sad.
Okay, Eli, I'm worried about you. I need to call home or something. I'm worried about your son.
I saw someone's photo.
Wait a minute.
Oh, I forgot to do something. Oh, we'll do it right now. Okay, go ahead and do page 6, just 1 and 2 at the bottom. We'll come back to the top tomorrow. Sam, I asked you to stop clapping, so you continuing to clap is not okay. We're still recording.
Only one, right?
Both of them. Page 6, 1 and 2.
Yeah, miss, I'm done.
Okay, now number 2, they try to trick you. They try to make it all fancy on us. A triangle ABC with AB met. Oh, actually, it does matter, I guess.
Still the same thing.
Okay, what did you guys start with? 7?
7.
Okay, so 7. ¿Dónde está lápiz? So 7 would be this one, right? And that's labeled BC, right? BC. Each dot would be a letter. And then 4, I guess it doesn't really matter, right? Because they're both 4. So this, and then this, and then put a dot. What is this point on the top called, though? What should I label this dot? With what letter?
A.
A. AB is 4 centimeters. AC is 4 centimeters. Okay. Before we move on to the next page, let's name it. What would you name number 2? What kind of triangle would you name number 2? Obtuse. What angle is obtuse?
Scaling triangle.
Wait, let's go with Noah. He's doing this angles. He said obtuse. So now I'm asking him, what angle of this triangle is obtuse? You are correct, but now can you identify which angle is obtuse?
No.
Okay, can someone help Noah identify which of these 3 angles is the obtuse angle? A. This angle right here is 100% obtuse. So if this angle is obtuse, then we call the whole thing obtuse. Now, Santiago, what did you name it?
Scaling triangle.
Why did you name it scalene?
Miss, can it be isosceles?
You just guessed, man.
Why is it isosceles, Riley?
There has 2 equal sides.
Exactly. Because it has 2 equal sides, it can only have one name if it's 2 equal sides. And that is isosceles. So, I name this triangle with all of my math powers isosceles obtuse. Isosceles obtuse. Yes, whatever. It's cool. You know. You can flip the names. Okay, what do we call number 1? What do we call it based on the sides? That's the easiest one.
What the one song says?
Scalene. Name it. For your test, you're going to have to name them. So pay attention to how I'm naming them. Your test is, can you name them? So, I have a 2, 4, 5. That means no sides are equal. Scalene. Now, I'm going to get you a protractor in a minute. What is this? Acute, obtuse, or right? This one. That one's acute. What about that one? Acute. Now this one. Obtuse. Now you're going to have this in a couple of minutes.
We're going back to the old days.
Still obtuse? Yeah, right? Obtuse. So this one's obtuse. So check all three. Check all three. Okay, what do we call it? A scalene what? Obtuse or obtuse? Scalene. Okay, we good? Okay, go back to page 2 while I pass out the protractors. Can you name it based on the sides only? Unless it's very obvious that it's acute or obtuse. Can you name it based on the sides? Page 2, page 2, page 2.
And you're trying to call the mechanic, but then you actually call Meriwether.
Name them.
Huh.
Name them.
Make sure you wipe it
I
down.
was laughing.
Name them, name them, name them.
When I'm writing in my hot dog.
So name them. Only by the side, because you didn't have a protractor. So it's really easy to name them by the sides. One equal side, no equal sides, 2 equal sides, 3 equal sides. Okay, number 3. What'd you name it? So, look at it. It's 3, 5, and 7. So go to your notes. Which one do you call one that has no equal sides? Scalene. The one that has the weirdest name is the one that has no equal sides. All right, number 4. Look at all the numbers. Again, scalene. This is why I asked you to put the numbers when you were drawing them.
I thank you, miss. I thank you.
Whoa. Number 5. How many sides are equal?
I didn't read that video.
2, so it's isosceles. Very good. Number 6. Equilateral, because all the sides are equal. Equilateral. Okay, number 5. Number 3. Now go back and name it based on the angles. Acute, obtuse, or right. This one's obviously acute, right? This one's also acute. What about this one? So take your protractor and measure this one. Is it above 90 or below 90? So Santiago, take your protractor. And this one. Is it more than 90? And feel free to rotate your packet. If you feel more comfortable rotating it, I want to know if this angle is more than 90 or less than 90 or equal to 90. It's more than 90? I know, but I gave you the actual tool to actually measure it. I'm not looking for the measurement. I'm just looking, hey, is it more than 90 or less than 90? More than 90. So this one's obtuse. So I put a little O for obtuse. I hope you're paying attention and learning. This is what's going to be on the test. So I got acute, obtuse. Who wins? Obtuse. You only need one obtuse, kids. You only need one obtuse. So this whole thing is called obtuse, scalene. Obtuse based on the angles, scalene based on the sides. All right, number 4. I know this is acute, and that one's acute. There's always one that's tricky. There's always one angle that I really can't tell. So go ahead and rotate your packet and put your protractor there. Correct. This one's actually a right triangle. This is actually 90 degrees. How do I tell you it's 90 degrees?
Telling me.
Dude, I'm supposed to be making like honors recommendations and not. And today has been the day where, oh my God.
Here, Eva.
Makes me cry. Makes me cry.
Hey, Miss, how do you find out it's the right angle? Because Evelyn tried being a smart aleck.
The box will tell you. But if there's no box, you would measure it. All right. The next one. This angle is what? What does that look like? A cute. What about this one? That one's a cute, right? These two are very obvious. There's always two that are super obvious. And then this one, I'm going to rotate it. You can also cover up this part of the triangle to kind of like isolate the angle. So this angle right here, what is it? Acute. So I got 3 acute angles. What do you call it? Acute. So it's an isosceles acute. So cute. So tiny. Isosceles acute. So you have to name it 2 ways, based on the sides and based on the angles. All right. Number 6, equilateral what? Acute. Because Padilla, what are all these 3 angles measuring? 60. Without doing anything now, every time, put this in the back of your mind, every time you have an equilateral triangle, you will have an acute triangle. There's no other option. Every time you have equilateral, you will always have acute. Always. And they're always going to be 60. You don't even need a protractor. It's one of those math rules. All right. Number 8. They already gave you one name for number 8. What do you call it? What do you call number 8? Isosceles what?
Acute.
Isosceles acute triangle. Yay us.
Oh, that's number 8.
We're good? Number 7, what do you call it?
Not working.
Not amigos. No triangle. Not amigos. I hope that's a choice on your SBAC. No, it's not a triangle. Impossible. Cannot make it. No bueno. Rejected. How else can I name it? All right, let's go over, because we got to make up some time. Let's go to number, actually, let's go to number 5 on page 7. Come on, kids. Page 7. Page 7. We got to make up Friday. Page 7, page 7, page 7. By the end of the week, we have to be able to name our triangles. And then return from spring break and still remember how to name them. Okay, number 5. A triangle with a base of 4 centimeters and base angles of 60 degrees. How would we go about this?
Convert.
Okay, what do you want to start with? What information do they give us that we can start with?
Triangle.
All of them are 4.
So, a triangle with a base of 4 centimeters. So, can we all do that?
It's a square. Oh, they said that all 6. Isn't it like the equilateral?
Yeah. So, we're going to start with 4 centimeters. So, draw 4 centimeters, Sam. You need to focus. So, we're on page 7, number 5. It says a base of 4. So, here's my base of 4. Then it has base angles of 60. So, which tool that I have? You have 3 tools in front of you. Which one do I use for angles?
Protractor.
A protractor for angles. This is your measuring for angles.
I knew that.
This is for circles and other things.
Making angles.
Okay, so we're making angles. So remember, the T goes on your dot. T goes on the dot. Make sure that this is pointing to the 0 on the 4. On the 4 side over here. Right here where the 4 is. So make sure that this is lined up to 0. All right, 60 degrees. Are we using the inside numbers or the outside numbers? Inside. So let's go ahead and use the inside all the way to 60. Put a little mark on the 60 right there. Put a little mark on the 60. Lift your protractor. Use it as a ruler. Draw a line. Now you're going to extend this line because I don't know where the other line's going to meet. I'm going to do a light, long line because I don't know where this line's going to meet this line. So I just draw it pretty long, kind of like your arcs. You don't know how long to make your arcs. All right, now I'm going to do the other side. So protractor, bump, just like so. Okay. Now I'm on the other side. I'm on this side. Am I going to use the outside numbers or the inside numbers? Now I'm going to switch over to the outside and put a mark on the 60.
Oh, it's in the letters.
60 over here on the outside. I'm going to pick up my protractor and I'm going to connect. But do I need to connect all the way or just to where the other line is?
Just where it is.
Just to where the other line is. This is 60 degrees. This is 60 degrees, right? Now, if I take my ruler and I measure these two sides, let's see what we get. What are the measurements of the sides?
4.
And? Yep. Olivia called it a long time ago. I heard her. And I was like,
Okay.
smart.
I see you.
So, what do we call it? Equilateral what? All your equilaterals will always be acute. I cannot say the same thing about an isosceles, and I cannot say the same thing about a scalene. But I can 100% assure you, if you have an equilateral, you will 100% have an acute. They go hand in hand, always. Okay, we gotta clean up fast.
Oh, sorry.